Hello and welcome to today's video. As you can probably tell from my voice, I've been sick. That is the reason why there's been a lack of videos being uploaded. So excuse any kind of sniffling or coughing or anything. I'm still trying to get over this cold. But anyways, on the workbench today, we have the Nissan Leaf battery management system. You can see I've got the cover off. This one is actually the one that I modified a while back. And it has my microcontroller, so you can see on the little purple board there. It is running the system. It's I got CAN bus up and running. I'm reading the A to D converter. I'm converting the system voltages and the temperature probes. And that's what we're working on today. If we were to follow this giant mess of cables, you'd eventually make it over to here. These are the 3 temperature probes. And you can see I've got them, if we can get focus to occur here. There we go. They are zip-tied to an aluminum heatsink with a power resistor. So you can probably figure out what we're going to do. This black circuit board here on the other side is a temperature sensor. It's an I2C temperature sensor, so you can see the 4 wires going into it. You got power, ground, and I2C. And that runs back over to the Pack Sniffer. So essentially what I'm doing is this top voltage, or top is the actual temperature, and I believe that sensor to be pretty accurate because it's room temperature in the basement, 22.18 degrees Celsius. The 3 lower voltages or the 3 lower values are the ADC voltages of the 3 temperature probes on the heatsink here. So if I were to just kind of lean over and touch, say, this guy, well, they are on a big heatsink. But you see I've affected the middle one. It went lower. Now it's climbing back up. So the hotter they get, the lower the voltage is. So it's kind of backwards on what I would expect. But that's the whole point of this. We're going to take this value and we're going to map it to these 3 guys. We're going to create a little table or a graph. So essentially what's happening is the BMS is reading, or my microcontroller is now reading via the A to D converter, these 3 sensors, 3 temperature sensors. It's just sending out a CAN packet that goes over to the Pack Sniffer here, which updates these guys right here. That's coming across 50 times a second. Excuse me. So, and we've got I2C coming in here, which is reading that other little temperature sensor that's also on the same heatsink. And you can see I've got this hooked up to the power supply, so I can run current through there to heat it up and change the values. So I've also got my Kevasar hooked up, and it's reading the CAN bus. So what this guy's programmed to do is anytime this changes, 1 bit change on the temperature, it's going to record that. So right there where it just toggled, it'll record the current temperature and what's being read by the 3 temp sensors. And it'll send that over a CAN packet. So over time, we'll build up a nice little table, which we can use to plot in Excel and get the curve for what the temperature probes actually are. So this is, I'm running a Kevasar's CAN Kingdom here. And if I turn it on, you can see this is my CAN data spewing across here 50 times a second. And you can see the values here are you know, the high byte, low byte, high byte, low byte, high byte, low byte, high byte, low byte. Of all 4 temperature sensors, we don't have one, and that one just reads this FDF. It's just kind of floating. But what we're actually going to do is set it, go ahead and stop it here. We're going to set up this acceptance mask, because this is all from 100, and 101 is what we actually want. That is when it changes, so we'll go ahead and start that again, and you'll see we get nothing because we have to wait for it to the temperature to change. So what I'm going to do is, currently we're reading 22.18. I'm literally just going to touch the heatsink, and you'll see that we'll get a CAN packet. So I'm going to go ahead and hold on to that. So I'll just heat it up here. And what was it reading? 22.18, and you can see it just changed to 22.25, and now it's 22.31, just from me touching the heatsink. and we've recorded 2 CAN packets. So every time there's a bit change, this, you can see it's 16.4, 16.5. The temperature sensor, for some reason, the data comes out of it left shifted. But that's okay, we don't care, we're going to convert it anyway. And then I've got the 3 other temperature probes. So you can see that 79E, 7A0, 798 corresponded to that 16.4, and then 79C, 79E, and 796 correspond to 16.5. So over time we'll generate a really big graph that will have all this data. I'll be able to export this as a comma separated file, and we'll run it through Excel and plot the relationship. I doubt it's linear. It's probably going to be logarithmic would be my guess. But when it's done, we'll have that graph, and we'll be able to inverse calculate that and run it in the micro. And then we'll be able to spit out the actual temperature values here instead of just the raw ADC values. So essentially, we're just going to map the these values to be equivalent to that, and then yeah, so then we could spit the actual temperature out instead of the raw ADC values. But yeah, anyways, that's what's going on, and we'll just go ahead and I'm just going to run some current through this puppy, so go ahead and turn that on, and let's just put for now we'll put 100 milliamps through it, and that should cause the temperature to slowly heat up on there, and we'll achieve some steady state point. We'll grab some more data points. We don't want to go real fast because we want this value to be really close. So see, it's toggling now to 22.25 and 22.31, and every time it does that we get more data. So we'll make a nice little scatter gather plot and have all that to plot. It should be pretty cool. So next video we'll probably have it displaying the actual temperatures, and I'll show you the nice little graph in Excel, and it'll look pretty cool. Anyways, yeah, thanks for watching. Bye.